Hi students, so let us continue solving JEE questions from our Transcend material. Question number 16. So it says, inside a NASA test vehicle, a ball of mass small m is pulled along by a horizontal ideal spring fixed to a frictionless table. So imagine this is your turntable. It is frictionless, it is smooth, and a ball of mass m is pulled along by a horizontal ideal spring fixed to a frictionless table. So anyway you can imagine here there's an ideal spring which means massless, and there is a body of mass m. The vehicle has a steady acceleration of a and the ball is not oscillating with the spring stretched by x naught. So this spaceship, this NASA test vehicle which they are saying, is having acceleration. Now let us assume in what direction they have not mentioned. So let us assume it is accelerating in this direction. And they are saying that this mass is not oscillating. Okay, so basically it's not moving on this table. So with respect to this table, it must be at rest. Okay. Now with respect to this table, it is at rest. Okay, so if you are an observer in the table, if you are an observer in this lift, then this lift is accelerating with respect to ground frame, right? So that means this frame is a non-inertial frame. So there will be a pseudo force in this direction, right? So that pseudo force will be MA. And because of that pseudo force, it gets, in the question they said it is stretched. So your acceleration I have to assume in this direction, okay? Because they said the spring is stretched. So pseudo force will be now in this direction. So because of this pseudo force on the block will stretch, okay? So it will stretch by some distance which they are saying x naught. So if the spring will stretch. If the spring stretches by x naught, there will be a spring force k x naught. And with respect to this person, this object is not oscillating with respect to the table, so it is at rest, which means this force has to be balanced by the pseudo force. Pseudo force is ma. Okay. So this force is kx naught. This is ma. Another way of understanding it from the frame of ground is, from the frame of ground which is inertial, there is no pseudo force, right? But this test vehicle is accelerating, and if this has to be at rest with respect to table, then from ground frame this block also should have the same acceleration as A. So from ground frame, who will provide that acceleration? The spring force, which means the spring must stretch. So either way, if you observe this block from the test vehicle frame, then there will be a pseudo force, which will, the pseudo force which is Ma, will balance your spring force. Okay, so Ma will balance the spring force Kx, because in his frame there is no acceleration, so net force should be 0. But since he is in a non-inertial frame, there will be a pseudo force opposite to the acceleration of the observer. Okay, so this is in this frame. Even if you do the problem in ground frame, how will you do the problem in ground frame? In ground frame, this should have the acceleration same as the test vehicle. So if it has acceleration, then from ground frame, Newton's law is valid. So F should be equal to ma. Which F will provide this ma? The spring force. So Kx naught equal to ma. So whether you do the problem from ground frame or from the spaceship frame, both will give you the same equation. Only difference is, in this frame you will have to assume a pseudo force ma. Okay. So this is your equation 1. Now the question says, Suddenly when the vehicle speed has reached V, the engines turn off. So the engine turns off, thus eliminating its acceleration but not its velocity. Obviously the velocity because of inertia will continue, but acceleration will no longer be there. So suddenly when this MA will vanish, under the action of this force it will start oscillating, right? Because it will come back to its mean position, and because there is a inertia, it will overshoot, which is the block, it has inertia, so it will overshoot the mean position and oscillate. So the time period of that oscillation will be what? 2 pi root over m by k, which will be equal to 2 pi root over, what is m by k from here? M by k will be x naught by a. Okay. So x naught by a means, which is the right option? Okay, they are asking frequency. So frequency will be reciprocal, 1 by 2 pi root over a by x naught. So the right option would be option A. So nothing much is there. However, the point to realize here is initially the lift was accelerating and the block was not oscillating, which means it was in its mean position. And it's like similar to gravity. Okay, so when there is a spring like this and you connect a block, there is gravity, right? So under the action of this gravity, what happens? You have a stretch x naught, and that stretch will result in a spring force k x naught, which will balance your mg. So it will be in equilibrium, right? So similarly here also, that the role of gravity here is played by this pseudo force. Okay, so it's similar to k x naught equal to mg, similar to k x naught equals to ma. Suddenly when it comes to not rest, but its engines are shut off, so acceleration will vanish, the pseudo force will vanish. So this spring force will take the body back. Okay. The only difference between this and this is you cannot vanish mg, right? Because you need the block to still oscillate. You need block to be there, so you cannot remove mg. But here, even if you don't have a, then this block will start oscillating under the action of kx naught. Right? Here gravity is ever present, right? Earth is below this spring, so gravity will be ever present. But suddenly if you remove the acceleration in this problem, then under the action of kx naught it will oscillate. Right? Okay. Let us now see the next question. Question number 17. So question number 17, it says the string of a simple pendulum is replaced by a uniform rod of length capital L and mass capital N, while the bob has a small mass small m. Okay, it is allowed to make small oscillations. Its time period will be how much? So usually time period of a simple pendulum is 2 pi root over m by g. But that formula is derived with the assumption that this string is massless. So the whole force acts due to the mass of this bob, and the force will be mg. Okay. So this is the one that we study in our board syllabus. And time period of this is given by how much? 2 pi root over m by g. Now what they are saying is this string is replaced by a rod which has a mass capital M. So this has a mass capital M, and this bob has a mass small m. It is allowed to make small oscillations. We have to find the time period. So now this becomes a compound pendulum. Okay, so let us discuss compound pendulum. So if you have any rigid body, okay, which is pivoted here, it is pivoted here, and it is made to oscillate about an axis passing through the pivot like this, then the time period has to be found in what fashion? Okay, so let us say the center of in equilibrium, the center of mass will be just below this pivot, right? Because normal force will be like this, mg will be like this. So those two forces will balance, and also since they are acting along the same line, there will be no torque. So the system will be in equilibrium. Now, if you, let's say this distance is LCM, okay, which is what? Distance of center of mass from the pivot. If you displace this slightly, so the whole body now takes this form, then now the center of mass will shift somewhere here. Okay, so this will be your now LCM. Okay, so once it is displaced, the mg will act at this point, center of mass, right? So about this pivot O, it will create a torque. What is the torque? R perpendicular into force. Force is mg. The force, whatever force acts here, that will not create torque about that point itself, right? So what is R perpendicular? If you extend the line of force, this is the pivot, so this will be R perpendicular, which is same as this. So this is your R perpendicular. Now, if the angle by which it has been displaced is theta, then this is the opposite side of this triangle, so R perpendicular will be LCM sine theta, right, into mg. So that is your torque about the pivot. So from Newton's second law applied to rotations, that torque will be equals to I about O times alpha. Okay, so this will be LC mg sine theta equals to I about O into alpha. So alpha will be what? Mg LC divided by I naught. Now for small oscillations, theta is very small, right? So sine theta can be replaced as theta. And if the angular displacement is anti-clockwise, the torque will be clockwise, right? The force mg will create a torque this way, opposite to the angular displacement. So minus sign is understood. So this will play the role of omega square. So omega will be root over mg LC by moment of inertia about the pivot. So try to memorize this result. So for a compound pendulum, the angular frequency will be, or if you want to know the time period, what will be time period? 2 pi divided by omega, so that will be I about pivot mg LC. What is LC? Distance of center of mass from the pivot. So this result we have to remember and use it to find the time period for such distributed mass, okay, which is called compound pendulum. So let us try to find moment of inertia about this pivot. Here this is the pivot, so what will be moment of inertia? For this rod, it is rotating around an axis passing through its end, right? So what is moment of inertia for a thin rod? ml squared by 3 when it rotates about an axis passing through its end. And for this mass, which is a point mass at a distance of L, so moment of inertia will be mr square, here that r is L. ml square. So this will be m by 3 plus small l into L square. Right? So that is the moment of inertia. Make a note of this. Now we have to know LC. LC is distance of center of mass. Now here this small m is the mass of the system which is oscillating. Here that mass is what? M plus n. Okay, so this is m plus n. So please remember this, later we have to substitute. So what about LC? So to find center mass of this system, this is a rod and particle system. So for a uniform rod, center of mass will be at its geometric center. So this whole mass can be concentrated here, right? The whole mass of the rod, capital M, can be concentrated at its center of mass. And this particle has a mass m. So let's say this is the origin, because we want to find distance of center of mass from the pivot. So let us say center of mass is somewhere here. So this is your distance of center of mass from the pivot. And if I call this x-axis, then this also becomes your x-coordinate of center of mass. So what is the formula for x-coordinate of center of mass? Mass of first particle, right? Formula you write first. m1 x1 plus m2 x2 by m1 plus m2, right? So that will be equals to m1 x1. So m1 is mass of this rod, capital M, whole mass is concentrated here, so what would be the coordinate of this mass from the origin? L by 2 plus second mass is m. What is the distance from the origin? L divided by m plus m. So here if you take L common, you will get m plus 2m divided by, here you take L common, okay, then after taking L common, m by 2 plus m, we take LCM, 2m plus 2m, here 2m plus m. So everything we have found, right? So once we have found everything, let us substitute. So time period will be equals to 2 pi root over moment of inertia. How much we found? This I can write m plus 3m divided by 3. So m plus 3m divided by 3 m square divided by m is m plus m, g, right? LC, what is LC? LC is L times, let's see if it is visible or not. Yeah, L times m plus 2m divided by, means this will be here 2 into m plus small m, right? Okay, so the whole thing will be 2 pi. Keep looking at the options also. So if you look at the options, so you can see here, this is m plus m and m plus m will cancel, very good. L1 m will cancel, root over 2m plus 3m small m divided by 3 times capital M by price of small m, right? So that means which is the right option? So the right option is m plus 3m, m plus 2m, 2 by 3, L by G. L is the for m is the matrix. So this is option B. Okay. So this is how you have to solve problems when a distributed mass is made to oscillate like a pendulum.